Alright guys, welcome to week 9 FRQ video help. We're going to be going through the 2004 Calc FRQ here. We're going to be doing all three parts, A, B, and C for the beginning. And then we'll do another one after that, but only one part. So here we go. Here's my differential equation. And the first thing they want me to do is to sketch a slope field. Alright, so basically I just need to pick for each one of these points that have a dot on them, they want me to sketch a little slope to represent the slope at that point. So here, the coordinates are -1, 3. So if I were to go ahead and plug in those values, my x value is -1. My y value is 3. And so following order of operations here, this is 1, and this is 2, and so 1 times 2 is 2, and so at this point I should have a slope of 2, which is going to be a positive slope, a little bit steeper than a 45-degree angle. A slope of 1 is about a 45-degree angle, so if it's 2, it's going to be a little bit steeper than that, right? Alright, then we'll plug in the next point. For this point I would be plugging in 0 for the x and 3 for the y. And that whole thing's going to end up being 0 now, because anytime you multiply by 0, it's 0. And you know what? Just to save ourselves some time, that same thing's going to happen here and here and here, because you can't have, well, anytime the x value is 0, that's going to cause your slope to be 0. So we can save ourselves some time there and just copy that fact on all those other places. Let's take a look at the next one. For the next one, we're plugging in a 1 and a 3, and we're actually getting the same answer we got last time when we plugged in the -1, because when you square a positive, you get the same thing as if you squared a negative, so you're still going to get 1 times 2, and so you still get 2. So this slope is going to match this slope. And in fact, now I can predict then that since for all these points here, like here and here, they're going to have the same y value, so this part's going to be exactly the same. They're going to have the same outcome for x also, because even though they're the same sign, they're just opposite values of x, so they're always going to be the same. So no matter what, I can always just, whatever I get here, I can just copy it over here, and that's what I'm going to do to save myself some time. So here we have -1 squared, that's for this point, and plugging in 2 for the y, and so that's 1 times 1, which is 1. So we're going to have a slope of 1. And that's about a 45-degree angle, so that would look something like that. And once again, we know this side's going to have to be the same. Okay? All right, let's do one more here. I think we're going to end up with zeros here, if I'm not mistaken, but let's try it. So I'm going to be plugging in -1 for x and 1 for y. And since I'm plugging in 1 for y, that's going to be 0, which is going to cause the whole thing to be 0. And once again, whatever happens on this left side is going to be happening on the right side also. All right, let's go ahead and do these points down here now. So that's -1, 0. So I'm going to plug in -1 for x and 0 for y. So if I plug in -1 here and square it, I'm just going to get +1. And if I plug in 0 for y, I'm going to get -1. So that's going to give me -1 as a final answer. So this is going to be a 45-degree angle, but in the opposite direction. And once again, we're going to have the same thing over here, just because it's copied like that. And so there is our slope field. All right, so that takes care of the first one. And just so you guys know, that they usually are going to give you like 1 point for these types of questions, which seems lame because of how long it takes, but they're making it only 1 point usually just because of how simple it is. But actually, they're making this one worth 2 points. So this is the answer key here and how they graded it on this year. So let's see. They give 1 point for making sure they have a 0 slope at each point, x, y, where either x equals 0 or 1. So in other words, if you had all of these being 0 slopes, then that's enough to get you at least 1 point. And then if you have a positive slope for up here, and then negative slopes around here, that was the other point. So, but yeah, pretty much just like I told you though, they base the credit on whether or not you're getting positives, negatives, and zeros, right? So, but notice they didn't talk about steepness. Like even though this one's supposed to be steeper than this, it's just too subjective of a thing to measure, so they don't really care about that. All right, let's go ahead and take a look at part B here. It says, while the slope field in part A is drawn only at these 12 points, it's defined at every point in the xy plane. In other words, there's always a slope somewhere in this plane. Now the question is saying, describe all the points in the plane for which the slopes are positive. So now this is what I'll call a weird question, and it's weird because this is not a common question. You don't see it very often. And they'll throw questions like that at you every once in a while. And the problem with the weird questions is I can't really prepare you for those because, they're always different. But it is good to throw them at you once in a while we're in class, just so you kind of get used to that kind of situation where you got to think outside the box a little bit. They want us to talk about how can you predict where the points are always going to be positive. Well, it has to do with this equation up here. How can we always end up with a positive slope? Well, what would always make this positive? Well, first of all, we see that x squared is always positive, isn't it? So we have something positive there being multiplied by y minus 1. So the only way this can come out positive is if the y minus 1 is positive. So that means that y minus 1 needs to be greater than 0. Because if y minus 1 is greater than 0, that means it's positive. And if that's positive, when you multiply it by a positive, you get a positive. So in this case, if I just add 1 on both sides, I'm going to get 1. So basically, the answer to this question is just where are all the points in the xy plane where the slope's going to be positive anytime y is greater than 1. So imagine drawing an imaginary line here where y equals 1. Anything above this line, you're always going to have a positive slope. And anything below it, you're always going to have a negative slope. Well, excluding the zeros, of course. So I guess we should make note of that as well. So not, because we had points here as well, right, that were 0. Even though y was greater than 1, they weren't positive. So we also need to add another thing. We have to say that x can't equal 0 as well. So we have a positive slope for all values of y greater than 1 where x is not equal to 0. So anything on this side of the graph, oops, I went too far. Anything on this side of the graph and on this side of the graph would be positive. So basically, you just have to look at this and think, what would make this equation come out positive? Now, on your guys' practice for this week, I'm going to give you a different equation, so you have to think about it. Okay, it's not going to be the same exact thing that I asked here. It's going to be a little bit different, but the principle will be the same. So think about it. And you got to get kind of used to questions where they're asking you things that are unexpected. And you just got to learn how to think like a mathematician, not so much like a student where you're just following your teacher's lead, but thinking like a mathematician where you actually have to figure something out. Okay, let's go ahead and take a look at part C here. Find the particular solution to this differential equation if this is my initial condition. So these are the questions where, I've been telling you about. You're going to see at least one, and when you do see one of these questions, it's going to be worth a lot of points. So we want to make sure that we really know how to do these. Let's go ahead and begin here. So I'm going to rewrite my initial condition up here at the top since I've erased it, but the initial condition was f of 0 equals 3. Okay, so step 1 is to separate the variables. So the first thing I'm going to do is I'm going to divide both sides by y minus 1. So if I do that, I get dy over dx, and that's going to be 1 over y minus 1 over here. And on this side, we'll just have an x squared left since I divided it off of that side. The next thing I'm going to do is I'm going to multiply both sides by the dx. So if I do that, I end up with 1 over y minus 1 is equal, dy is equal to x squared dx. So right there, that is worth 1 point, just separating the variables appropriately. Just remember that when you do variable separation, you can only separate by multiplication or division. You'll never do addition or subtraction or anything like that. It's going to be multiplication or it's going to be division. All right, the next thing that we're going to do is we're going to integrate both sides, and you get 1 point for integrating each side. So this side's going to be an easy point. That's where you just add 1 to the power and divide by that value, and don't forget your plus c. So there's another point that they would give you. Now this side's going to take a little bit more work. Now you can do u substitution, where you let u equal y minus 1, right? But I also talked about a shortcut in class for these, and I'm going to go ahead and just use my shortcut. The shortcut that I shared with you guys in class a little while back, I'll remind you of what it was, just to kind of, in case you were absent, because that was senior ditch day apparently. But I'll remind you of what it was if you weren't there and you were a naughty senior. The rule is this: if you're integrating a over bx plus c, if you ever have one that takes on this form, where you have just a number on the top and then a linear function on the bottom, the integral of that is always going to be this number on top over this number on the bottom with an ln, absolute value of the bottom, like that. So it's a nice little shortcut, and I think that it's something that you'll want to know if you can try to squeeze one more fact in your head. But if you're not interested in squeezing one more fact in your head, just know that you could just do u substitution where the u is the bottom. But I'm going to go ahead and go with the shortcut. So for my shortcut, this is going to be my top number. The number in front of the y is a 1. And then we have ln of the absolute value of y minus 1. I like my shortcuts, so I'm going to use it. Anyway, so there is the integral the other side. And that also is going to be worth 1 point. So now we're up to 3 points already. And honestly, even one more point, even on this problem alone, would be enough to get a quote-unquote passing score for this particular FRQ. Anyway, let's go ahead and continue. So we have 1 point for separating the variables. We have 1 point for each of these integrals for a total of 3 points already. So let's go ahead and move on to the next point. The next point is to find the c value, and you do that by plugging in your initial condition. I'm going to plug in 3 for y and 0 for x. So here we go. So this whole thing's just 0, and this is 2. So c equals 2. So voila, I've got another point. Now I'm up to 4 points. And even if I didn't answer any other questions on this particular FRQ in parts A or B, if I got this far on this question alone, I would already be like in passing zone for this particular FRQ. So you can see these questions are really important. So there's that. All right, so there's my particular solution, but I do need to get the y by itself, and that's the last point. So the first thing we want to do is I want to get rid of this ln. And the way that you get rid of an ln is by exponentiating both sides. So let's do that. So exponentiate means you're going to do e ln on that side, and you're going to make the right side an exponent of e also. All right. Now the e cancels the ln, and it leaves me with the absolute value of y minus 1. All right. And then the next step we're going to do is we're going to get rid of these absolute value bars. And that gives us a plus and a minus on this side. And then finally we can add 1 on both sides to get the following. All right. And so we're not going to leave it where we have a plus or a minus, right? That's 2 different possible answers, and we have to find which one's right. Is it the positive e or is it the negative e? And for that, we use our initial condition to decide. So I'm going to replace this y with 3. So I've got 3 equals, and I'm going to go with the positive e for now. So we'll see if that's the correct answer. And I'm going to replace the x with 0. So it's going to be 0 cubed over 3 plus ln of 2. All right, so that's going to all just go away there. And we don't really need to write the plus, so I'll just leave that off this time. And these cancel out, leaving me with 2. And sure enough, that works. So it turns out then that our answer is the positive one. So, and for an FRQ, that's really good enough. So I'll go ahead and write out the answer, but and I want to show you some other stuff you could do with it, but I wouldn't go farther than this on an FRQ typically. So I'm just giving it to you in case you see a question similar to this on a multiple choice. My advice would be to stop here, right? But we did talk about a little bit how you can write this a little differently, because on a multiple choice, they would probably do this. They would split the power up into two separate e functions being multiplied together. This piece just becomes 2, and they would probably just put that 2 right there in the front like that. And so that's probably the answer they would show on an answer key. But personally, I would say just leave it like this. They're not going to penalize you for that. That's a good answer. So anyway, so that being said, you can kind of look at how they're grading here. Separating the variables is 1 point, like I mentioned. Both integrals or antiderivatives, if you will, that's 1 point. Getting the constant of integration. In other words, I think on this, I don't think they do this anymore, so I don't want to say they do this, but just writing plus c, they give you that 1 point, which I think is really kind of silly, but okay. And then using the initial condition, not even necessarily finding c, but just taking the time to plug in the initial condition, they give a point for that, and then solving for y. So there you go. They talk about a few other details down here, but anyway, let's go ahead and move on to the next part of our FRQ, notes. And this one's on page 30 of your FRQ notebook. And on this one, we're not going to do the whole thing. We're just going to do part C, which is just another one of the ones we just did, but I like to drill those a lot just because they are so valuable. So same question, just different function with a different initial condition. My initial condition is f of 1 equals -1. So there we have it. Let's go ahead and begin the problem then. So once again, step 1 is to separate the variables. So I'm going to multiply both sides by y and dx. Now if I do that, I get the following. So that's worth 1 point. The next thing I would do is I would integrate both sides. The left side is going to become y squared over 2. The right side is going to become -x squared plus c. Next, I would go ahead and plug in my initial condition to find c. So I'd plug in -1 for the y value. If I do that, I get a half. And I'd plug in +1 for my x, and I would end up with -1. And then by adding 1 on both sides, we end up with c equals 3/2. Now, how did I get that? Well, you'd have to get a common denominator, right? Now together, but you get 3/2. So, so far then, we have y squared over 2 is equal to -x squared plus 3/2. Or, you know, if you like decimals, you could say 1.5 if you prefer that. Now we got to get the y by itself. So we'll multiply everything by 2. So if I do that, we'll end up with y squared equals -2x squared plus 3. And the last thing we need to do to get y by itself is we need to take the square root on both sides. And as you guys know, whenever you take a square root, you get a plus and a minus. And we have to decide which one it is. So the way you decide which one it is by plugging in your x and your y value and seeing which one works. Okay, so we have y is equal to, let's go ahead and pick the positive one. So I'll just pretend there's no negative in the front for now. All right, so my y value is -1. My x value is 1. Oh, okay, so I made a boo-boo here. Let me back up a little bit. It's not supposed to be -4. -2 times 1 is -2. And so that's not a true statement, right? If I take the square root of 1, I get 1, and this is not a true statement. Therefore, picking the positive one was the wrong choice, and it must be the negative version, and therefore this would be the correct answer there. All right, so there's our final answer, and that's the end of that particular problem. So hopefully that was helpful, and good luck with your FRQ practice, and we'll see you guys in class.